Good afternoon, everyone. Are you able to see the screen?
Yes, sir.
Yes, sir.
Okay, we'll start the planetary physics. This is the 16th class. I'm having some classification actually, not an issue. How are the things with you? Fine? How you have prepared for tomorrow's event? How you have prepared for tomorrow event? Is there any event for tomorrow? Suresh Babu, sorry, Naresh Babu?
Yes, sir.
Is there any event for tomorrow? Planetary events, solar events, not the event at your home or maybe somebody's home.
Yes, sir.
Yes, sir. You
What is
have
that?
mentioned something.
But
You have mentioned something in our book.
solar eclipse.
That was the.
Okay, think. I sent a message to fourth semester group actually. Of course, you are also there in the fourth semester
Yes.
instead of planetary. Just think it up. That is for monsoon, I told. Eclipse also you try to see that. We will explain tomorrow if it requires. We'll see that. We will be directly under the shadow of the eclipse. May not be to India, but that time slot, whatever 3 to 4 o'clock class is there, that regular class fits with that thing actually. Okay, here, no problem. First unit was over, and let us switch over to the unit 2, where it deals with the planetary physics. There is no doubt. In the planetary physics, we are having what we can call the planets of our solar system. Planets of the solar system goes with some 9 topics, broadly, you can say that. Maybe the sun and the planets of the solar system, of course, belongs to the solar system, they can call. Titius Bode rule to find the position of or distance of any of the planets from the sun. It is in one of the what method they can call semi-empirical mass flow law we are expecting. It is a semi-empirical rule actually. Okay, and one can able to estimate the orbital velocity of the planets which are revolving around the sun, and surface temperature and bulk densities of planets. Some physical parameters they can call, how that temperature can vary, what must be the value of the temperature, how they are estimating if there is a possibility, how the density varies, and how orbital velocity of Ceres system can go, particularly the radius and volume of the rocky core, how it will go of the particular Pluto. Okay, planetary evolutions is the next subtopic actually, how that planets have evolved, including Earth actually, growth from planetesimals actually, in the sense if you want to know if you want to understand the planets of the solar system, one should understand the Earth in particular. That we have done so far in the third semester, and some internal differentiation either in terms of the temperature or in terms of the density or in terms of the pressure gradient, how that interior of any of the planets have been formed or made. Then atmosphere of different planets, internal structure of the Earth. Of course, this is well you are aware actually as in one of them, like an interior of the Earth, particularly in terms of the temperature, melting point of periodite actually, then mantle plumes, plate tectonics, magnetic field of the Earth, and of maybe even for solar interactions also can go, interaction with the solar wind, then meteorites and their impact on meteorites and impact craters they can call actually, classification of mineralogy of meteorites, then carbonaceous chondrites and tectites. I'm surprising that actually when we are hearing some of the words as the first time actually, this terminology one should have. These are all science terminologies only. Nothing is new in that at least. We'll go one after the other. While starting the classes for the fourth semester, we discussed a lot on planetary physics. We discussed a lot on the solar system. We discussed a lot on the what we can call it is the celestial bodies to a great extent. Keeping in mind the second and third unit, both together, either the planets of the solar system or evolution of the planetary system, or even the third unit mainly concentrate for the terrestrial planets like Mercury, Venus, and Moon actually, of course, including Mars. Then maybe some detailed studies about the Moon and Mars is there. Keeping in mind, we discussed. I spent more time, about some 2 to 3 hours actually, in elaborating the discussion. Then we jumped onto the orbital motion and as well as the orbital dynamics. Okay, in total it took about 15 classes. That's not number of the classes. We took almost some 15 sessions of that kind. Let us see how it has to behave. You may recall what we have discussed actually. I am repeating first few slides. then we'll switch over to that. What best we can do it here is that left side there is a sun, of course, there will be sun always, and planets are on right side. It is only for schematic representation. It will never happen in the same linearity. Okay, of course, planets are also shown according to their size, relative sizes they can call actually. This is the size of first planet is in the order of their occurrence they can call. First planet is Mercury, second is Venus, third is Earth, fourth is Mars. Fine. These up to this extent they will call it as the inner planets. Even they will call it as the terrestrial planets. After that, fifth one is the Jupiter planet. Okay, Jupiter, Saturn, Uranus, Neptune, Pluto is excluded from 2006 by International Astronomical Union, IAU. International Astronomical IAU, we can call. Till 2006, whichever may be the books you refer, or maybe whichever may be the reference material you are referring, or maybe quote actually, certainly they might have included the Pluto as one of the planets for the solar system. Later they have excluded mainly because where the celestial body does not meet all the properties of the planets which belongs to the solar system. That is the only reason. Nothing we are against to the Pluto. We are not having against to the any of those classification of that kind. We are not favoring. We in the sense the human scientists are not favoring any of the planets actually. But as such, it does not meet certain criteria. Because of that, it is excluded. Fine. This parallax has shown. Sun is fairly an ordinary star. It is not like that other kind actually. Compared to the other systems, Sun is a fairly ordinary star. Ordinary star means like other stars, so Sun is also one of the stars actually. With some classification they can call. Sun at one of the foci, Earth can go revolution around it from west to the east actually, moving in an anti-clockwise direction as we see from the northern hemisphere. Fine. If that is the case, it has to be at some point it should be near to the sun, at other point it should be relatively far away from the sun. Average distance will take it as the one astronomical unit AU, about 150 million kilometer. Okay, between equinox, you can say that almost 150 million kilometer. Solstice either for summer or maybe winter will be. Particularly if the northern hemisphere is having a summer solstice, they can call. Earth will be at a distance of about 153 million kilometer, and it will be in the winter where the southern hemisphere is direct exposure to the sun at a distance of about 147 million kilometer. Don't expect that at least whenever we are nearer, we are feeling summer, and when we are away, it should be winter of that kind. Purpose is that even though the Earth is nearer, the atmosphere makes as one of the attenuator for incoming radiation. The radiation may not reach since it is tilted outward. Okay, outward during the summer season. As you see from this star, of course, either you can see in the month of the August or you can see in the month of the February. They can call actually. You have to see the one star which is a reference star. They can call Pleiades. Okay, Pleiades where seen against these objects in February. Here this is seen against the objects in the duration of the August. Not one star. This is a group of stars they can call, group of stars. How that background would happen. This parallax one has to expect. In the background you can see all the stars put together. This is the beautiful diagram of the galaxy in the background. But the dimensions are not to the scale. Just they have taken this one. Being this is like hundreds and billions of stars that make up one galaxy. That galaxy, one of the galaxies is known as the Milky Way galaxy. Andromeda galaxy is the nearest galaxy for us actually. Milky Way galaxy spirals around it, which is some common center of mass. All of them are the stars, millions of stars, not million, billions of stars are there. After billions of the stars, within one star is the sun actually. In one sun, we are having 8 planets. Out of 8 planets, Earth one among it. Out of the Earth, actually, we are staying in northern hemisphere. In the northern hemisphere, somewhere India. In India, we are at somewhere Bangalore, Karnataka, or maybe a Bangalore, or maybe Gauribidanur, or maybe a Kolar, or maybe Chintamani, or maybe Bhagyapalli, or maybe in somewhere house, somewhere in one of the room, and you are right now listening to me and you watching the display, how it has to go. It is a huge system. These distance and dimensions we explained. Of course, as just to think it out, this is how it has to go. Okay, let us see that how this is the spiraling around. We are in a galaxy they can call. This is the sun's orbit. Yellow color is the sun's orbit actually. Okay, we can have different things. Milky Way is a spiral way of the galaxy. It is a bad spiral galaxy of that kind with some barriers. 4 barriers are there. According to the best current knowledge, whatever we are having so far, the Milky Way is almost about 150 to 200,000 light years across. The diameter, if you go 150 to 200,000 light years. Light years means light year is nothing but how long the light will take Electromagnetic radiation, how long distance I am saying that, how long it will travel in 1 year is known as the 1 light year. And about the 2000 light years deep, in terms of the deep, depth wise about 2000 light years deep, and thus has about 100 to about 400 billion stars. Here we mentioned about hundreds of billions, about 100 to 400 billion stars it is composed of. There may be a 4 primary spiral arms emanating from its central bar. This is the central bar what you are expecting, actually galactic bar of the kind here. Okay, here the same thing, galactic bar of that kind. 4 spiral spins, this is the one, then 2, maybe 3, then the last one 4. Emanating from the center bar with an unknown number of smallest offshoot of the arms they can call. V means sun actually, or even earth also you can take, not an issue. About 26,000 light years from the center of the galaxy on the inner edge of the Orion Cygnus arm. Inner edge of the Orion Cygnus arm. This is the Orion Cygnus arm is there, no? This is the inner edge you can call. This is the inner edge where you are expecting that should be the position of the thing actually. This is also a representation of our galaxy, like entire Vishwa they can call. Okay, Prapancha, what you are calling, is one among the billions of galaxies or star clusters are put together is known as the universe. Okay, galaxy, this is somewhere here. This is another picture. This is also another picture. How they will take this picture is a tough task. By getting the radiation or by observing the radiation coming from different stars and different galaxies, different Milky Ways, they will estimate the position of the stars and the galaxies by their time of occurrence and the intensity or strength they can call. It is a separate branch and it deals with the huge, not huge actually, but rigorous mathematics and rigorous physics out of it actually. Time permits, we will see that. Of course, in astronomy they will learn a lot, but as in space physics or planetary physics, we will go as touch upon them actually how it works. We will concentrate much for planetary physics of that kind. The same thing here, sun is somewhere here, here. There is only a one dot. Okay, I can show here. Normally, while galaxy is rotating, actually, sun and planets in the solar system comprise only a few small part of Milky Way. When it was formed, assume that it was a linear line like that. Then it started rotating at any time at any amount of time they can call it spirals. It spirals means this outward like that, outward here like this, it's coming and going, means anti-clockwise direction. Okay, after 15 million years, it might have taken this shape. After 100 million years, see the shape right now. This you can just put it here in such a way where how you are getting actually. This is the case. About the time is several billion years ago, how it was there of that kind. The bottom panel shows that the solar system with the sun at one of the point actually where planets are revolving around it. And here you can see that there is so much of the heaviest materials which are encircling after some planet between that actually. We will see one after that. There is a beautiful planet with the some rings. The planets are revolving, planets are having satellites around it in revolvement that it looks like a belt. This is one of the hugest or biggest planet. They can call it as a Jupiter right now. We'll take it up. What it means, the solar system is dominated by the sun. There is no doubt out of it. We also know and you are well aware of it. Sun is a fairly an ordinary star. That is the reputation fine. Like hundreds of billions of stars that make up the galaxy. We are staying in a Milky Way galaxy. It is not made up of milk and it is a milky they can call, like a bright they can call. Our galaxy is one among the billions of the galaxies for star clusters. In general, it is known as the universe. Praveen is there? Yeah, Praveen. You just go with some other study in such a way that how that the universe and galaxy is made up of different stars and other things. Maybe you can compare with that the mythology, but don't go against with the physics out of it. Sun and planets of solar system comprise only a few small parts of Milky Way. Galaxy itself is like a grain of a sand on a beach. If you are walking on a beach, one of the grain looks like a galaxy. Our galaxy, Milky Way galaxy, is only one grain. You imagine you take one handful of the sand, so much of the galaxy is actually in your hand. Okay, then you compare with the left to right and right to the left of that can be east to west and north to the south, how that beach is covered with this sand. Okay, so much of sand granules makes up the universe. It is only an imagination. Imagine the earth and all of us who live here are part of the universe. Okay, there is no doubt we are part of it. In fact, universe is not just compressed of space and galaxies of stars, but it is also including our living rooms, our physics department, our home, where we live in either in hostel or right now in the pandemic in our own house actually. In fact, the universe includes us, and all living organisms need not be restricted for the mankind. Maybe all living organisms, maybe flying birds, or maybe moving ants, or maybe in what they can call marine organisms, marine living organisms. Some of them are living underneath the earth, some of them are living in air, some of them in space. So many things. Maybe whether we can have that what we can call what they can call that is coming from other planets. Just I kind of word by forget it. I will let you know actually. Maybe another kind of living organism. Since this is considered the Earth as the biggest, largest planet, no doubt, its orbital velocity is about 1 million times smaller than the its volume. Its volume is about 1 million times smaller than the volume of the Sun. This is only a small part of it actually. And the distance between the Earth and Sun is about 150 million kilometers. And sounds like a long distance, of course. But Earth is very close to the Sun with about within the solar system. And solar system can go up to about 50 astronomical units. Okay, no doubt. Where you can find some of the clouds they can call Woods clouds. Actually. However, Wood cloud is beyond 1 lakh astronomical unit. Think that the 100 years is a long time and celebrate in 21st century. If you consider it began about 10,000 years ago, only about 100 centuries have passed. Okay, actually, 1 century is insignificant compared to the age of the solar system. Solar system is about 46 million centuries old, 4.6 billion years they can call. Okay, that you might be estimating from the carbon dating or maybe the life of the uranium, lifespan of uranium. They have explored the Earth and are now exploring the solar system. What are all there actually? Humans have certainly accomplished a lot in the past 2000 years. Okay, that's the roughly they can call 2020 right now you can call. Okay, broadly you can classify them, Sun and planets of the solar system as they are all celestial bodies of solar system. It can be classified into one of the definition laid down by the IAU, International Astronomical Union, which was defined on the August 24, 2006. On that day onwards, they excluded the Pluto as the planets. Okay, why this date is required? 2006 is fine, no problem. But the classification, you should not refer to the textbooks or reference books which were earlier to that were published in a hard copy, where hard copy. Of course, soft copies they might have modified in the internet resources, information will be updated. Planets are celestial bodies that orbit the Sun, there is no doubt, which have sufficient mass for their self-gravity. If they doesn't possess this mass, sufficient mass for their self-gravity, they may not call them as planets. And it can overcome the rigid body forces so that they assume a spherical shape, there is no doubt. And they have cleared the neighborhood around their objects. Because of the existence of the planets, the neighboring objects like smaller masses will be cleared mainly because that will be directly under the continuous interaction of the planets. Dwarf planets are less massive compared to that of the planets. They do not have spherical shapes, maybe some other kind of a shape. They have not cleared their neighborhood. This is some other objects should be there surrounding them and their orbits. And they are not the satellites of that orbit in the sense, because it's not. Moon is also neighboring thing for us, but Moon is this one of the satellite. Only one, not only one and only the satellite for the natural satellite. One and only the natural satellite for the Earth is the Moon actually. Jupiter, Saturn having n number, maybe larger numbers. Small solar bodies, some small solar system bodies they can call, orbits the Sun. Need not be either planets, dwarf planets, even some small bodies, but do not have sufficient mass to achieve the spherical shape, and they have not cleared the neighborhoods around them. They are called the meteorites, asteroids of that kind. This is diagram you have seen. Sun at the left side, and this is one of the things actually. See that this is the one of the Greek terminology used for explanation. savior for Mercury, morning star they can call for Venus, Earth, red planet they can call it for Mars. Okay, asteroid belt in between the Jupiter and the planet. Oh my God, this is called the Almighty God, Guru Graha. Okay, Jupiter, and this is known as the conites, particularly for Saturn. In terms of H cross, they can call actually. This is the mediator, Jupiter, Saturn, okay. Then what they can call 4, 5, 6, 7, 8. This is the Neptune. They can call. This is Jupiter, Saturn. Sorry, what is that? Jupiter, Saturn, Neptune, and then not Pluto. What is that in between? I just missed.
Uranus.
Uranus. Sorry, no. Uranus, then Neptune. Uranus and Neptune actually. Then this belt, Kuiper belt, they can call. Kuiper belt. This is the last term. That's the last celestial body which belongs to this solar system. They can call actually. Here are kind of Kuiper belt. Okay, this we discussed. Here also we discussed it by some other representation. I will not go through it actually right now. Okay, we have discussed this. You can have it, not an issue. The new definitions are the solar system has only 8 planets. There is no doubt. In the order of their occurrence, starting from Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, and Pluto and other asteroid series are now classified as what is that? Asteroid belt. Here, this one, and the series is also treated as what you can call asteroid belts actually, dwarf planets they can call, which is a new category that will eventually include the largest of these spherical ice bodies that occur. They may not be in this spherical shape, occur in the either Edgeworth Kuiper they can call, or maybe Kuiper belt in the space beyond the orbit of the Neptune. Sorry, beyond the orbit of the Neptune, what you are getting actually, this is Uranus, then Neptune. This you can get the Kuiper belt. Okay, Kuiper belt. All of the asteroids except the Ceres, Centaurus, comets, and other small ice objects that occur in the Kuiper belt and in the Oort cloud are now classified as small solar system objects actually. Here, small solar system objects they can call. 2006 onwards, this is the classification. Okay. The new definitions adopted by IAU do not specifically address the objects that orbit the planets of the solar system, except to exclude them from the category of the dwarf planets because they do not orbit the sun. They may orbit something else actually. Something else may not be exactly within the sun. That means they should not have the periodicity. However, several satellites of Jupiter and Saturn have larger diameters than the planet Mercury. Planet Mercury, if you compare that, compared to that, the satellites of natural satellites of the Jupiter and Saturn have still larger in diameter, but we should not call them as the planets. We have to call them as the natural satellites. Therefore, we will continue to use the term satellite to describe the celestial bodies of any size and shape of that orbit. But any of the 8 regular planets of the solar system, reserve the name Moon for the satellite of the Earth alone. Don't call the moon of Jupiter, moon of the Saturn, moon of the rest of the planet. Of course, satellites of Jupiter, satellites of Mars, satellites of something will be there. They're having a different names. The word moon refers to the Earth alone. Moon is having a great impact tomorrow. What it will do tomorrow? What is the role of a moon tomorrow? Wahida Banu, Ayesha. You may be fed up with KN this time. You can unmute. Both of them are not there. Arpita, Ayesha, Wahida Banu, Arpita. Okay, not. Anyhow, today, Praveen Kumar, what is the role of moon for tomorrow? Whatever he plays today's role, he will play. The same thing will be played for tomorrow also. Is it the same case? I don't know. After the class, you just watch TVs. All the TVs you are having an astrologers. I thought that today and tomorrow should be entire media should address the astronomy. Entire media should address the planetary physics. Entire media should address the atmospheric physics. Entire media should address the solar physics. Instead of that, they are going with the astronomers, right? They let them go. It's not in our hand actually. Okay, the orbits of the planets. Okay, where we were there? Somewhere we missed. Okay, the moon plays very important role for tomorrow, as equally as the role of the sun, as equally as the role of the Earth. Actually, the orbits of these planets and asteroids are confined, okay, to a narrow region of space aligned roughly with the equator of the sun, almost parallel to the equator of the sun. For example, here, see that this is along the equator only it has to go. Where you can see the belt. This belt you can't expect it for somewhere else. This should be parallel with the equator one day. Okay, with some tilt will be there. That is what we are expecting. The orientation of the orbits comets range more widely than those of the planets. Of course, comets will have more orientation. It may not be exactly parallel to the equator. Comets may enter solar system both from above and below planetary disk. You think of a disk like a plate. Okay. In the plate, you can have all of them put together, but they may also enter from the top and bottom. There is no doubt. Mercury and Venus are the only planets that do not have at least one satellite belongs to them. The number of known satellites in the solar system has increased from 59 during 1991 to more than about 120 because of many additional satellites of Jupiter, Saturn, Uranus, and Neptune, which have been discovered recently with the modern astronomical telescopes and by robotic spacecrafts like Voyagers, Galileo, Cassini. Maybe Chakravarti sir might have discussed with Voyagers, Galileo, and Cassini during his discussion on our planet physics. Being this is what we discussed earlier as a preamble. Again, I recapitulated it. Fine. I brought to the notice. Let us see some pictorial representation. How they are there. Whatever the diagram you have shown in a textbook for high school, for even middle school, primary school, or even in a college level, even at graduation, the solar system does not look like that. Okay. Means I am not against that. It is not the way. Earth you have shown always spherical. First circular, no. Next spherical, no. Next geoid, maybe. Then some other shapes you can expect because of the valleys, mountains, and another part of that. Okay. Sun always we have shown one circle with red in color. Okay, white during daytime, maybe red during sunrise and sunset, yellow during some other time. When you are expecting the radiation to pass through a prism, radiation coming from sun, which is the color you are observing? Anyone answer from your side? Which is the color of the radiation which is entering into the prism if the radiation is coming from the sun? Or if you look towards the sky, particularly towards the sun, what is the color of the sun? Anyone? Suma?
White color.
White color. Very good. Shekhar? Shalini? Arpita? Oh, they are silent or they are just switched on the device and might have gone somewhere else. White color is the color of the radiation which is coming from the sun. Okay. After allowing that one to pass through the prism, what color you are getting? Which are all the colors?
Vibgaya.
Vibgaya. Oh, Vibgaya is a color. Okay, that is the spectrum you are saying.
Yes,
is it that is the only the radiation which is we are receiving from the sun, or it also includes with other spectrum? Other spectrum is other wavelengths or frequency. In the visible, we are getting spectrum like visible, Vibgaya, but radiation coming from sun includes all the all the wavelengths of the electromagnetic spectrum, starting from gamma rays till to the extent of the radio waves. Okay, that we'll see later. Okay, here if you see that actually solar system is the assembly which is consisting of the sun. There is no doubt. An orange star in the Milky Way galaxy. It is nothing special about the sun, but everything is because of the sun. Here, if we concentrate for the atmosphere, if we concentrate for the planets, but those bodies orbiting around it, right now 8, earlier it was formerly 9 planets, with about 210 known planetary satellites they can call. Of course, they are including something else here, including moons, countless asteroids. Countless means it is not a new number, but large number they can call. Some with their own satellites, some of the planets with their own satellites, and comets and other icy bodies, comets will be there. Here you can say that comets, maybe the icy bodies, and vast reaches of the highly tenuous gas. Some gas, tenuous in the sense very thin gas and dust. Entire thing put together is known as the interplanetary medium. Entire thing put together is known as the interplanetary medium. Interplanetary medium comprises of the star, maybe like one sun, planets, maybe whatever may be the number, asteroids, meteorites, then satellites, maybe then icy crystals, comets, icy bodies of that kind. This is a mixture. This is a mixture you are observing in the boundary actually. Boundary, whatever you are expecting. What is the thing? Just you think of. It's now we are moving relatively to and deeper in the strength and knowledge. This is the diagram taken from Encyclopedia of Britannica. Earlier encyclopedias were very well reaching the student fraternity. Now all of you have stopped reading the hard copy, hardbound books, and of course you are depending on much on the internet, and we also, there is no doubt, always all the versions are on with the e-copy of that one. Okay, that doesn't matter. Sun on left extreme, about 113, how much is there? 1.4 million kilometer is the dimension. 70 million kilometer is the radius. 70 million kilometer is the radius. 1.4 million kilometer is the diameter of the sun. First planet is the Mercury, about 5,000 kilometer in diameter. Second one about Venus, not about, second one is the Venus, about 12,000 kilometer. Third one, the Mars, about 6,800 kilometer diameter. Oh, where is Earth? Earth is here. Yes, Earth is somewhere here, about 12,760 kilometer. This is half of its value. Compared to that, it is the dimension of the Venus and the dimension of the Earth are one and the same thing. But dimension of Mars compared to either Venus or the Earth is half of its value, roughly. Okay. And for that of the Mercury, still lesser than the Earth, about 1/3 of it. But compared to that, you compare that with the Jupiter, it is one of the largest in terms of the dimension size, 143 million kilometer. This is this is how many million kilometers? 143,000 is not million. 143. This is 143,000 kilometer. Okay, or 0.143 million kilometer. It is 1.4 million kilometer. 0.14 and 1.4. You can make it, almost you can multiply this by 10. You will get this number. 10 times more. Sorry, Sun is 10 times bigger than that of the what we can call Jupiter, the largest planet on Earth, largest planet in the solar system. Or you can include how many they can call, instead of 10, you can include more than 130 Earth to counterbalance the volume. Mass they can call actually. If you multiply it by 100, it will not be there. If you multiply it by 130, you will get roughly about this number. Okay, and Saturn with beautiful rings. Here also beautiful rings are there. All planets after Mars are having the rings. Oh my God! In the mythology, Krishna was wearing ring. What we have heard actually. I am not on par with any of the mythological things actually. But think, just for remembrance, just for curiosity to have a comparison actually. It is rotating, revolving in particular direction. This is beautiful. It not be only single. It is a huge ring of that kind. Uranus, this is also, this 143 million kilometer is about 143,000 kilometer. This is 120,000 kilometer of that kind. Here this comes to be around 51,000 kilometer, roughly 50,000. Last two are 50,000 kilometer. Since last two are bigger than this, almost four times. The Neptune and Uranus are 4 times the Earth, and Jupiter and the Saturn are almost 10 times more. 10 times more, and the Sun is about 110, 120 to 30 times more than that of that kind. And the size also, see that similarly you can compare them. Now think of, if Earth encounters such a huge system like Jupiter, if Earth encounters such a huge system like Saturn, the Earth encounters a huge system like the Sun. Can you expect that Earth is only under the gravitational influence of Sun alone, or is it also under the gravitational influence of the Jupiter, gravitational influence of the Saturn, gravitational influence of the Uranus, Neptune? Means these 4 planets are known as the outer planets. These earlier 4 are known as the inner planets. There is a demarcation between Mars and Jupiter actually, and inner 4 planets are known as the terrestrial planet. they act like a terrestrial. They are having a land. They are not gaseous particles. The outer four are known as the gaseous particles. Sorry, gaseous planets I can call, or gaseous celestial bodies. Sizes given are of the approximate diameter of each of the body. What do you agree? Right now, the things are becoming complicated. Whatever we have shown, whatever we are reading to the students, whatever we are explaining to the high school and primary school students, actually, things are not happening in the same fashion. Now, imagine here, see the Jupiter, see different colors are there. It is also tilted by some angle with reference to the equatorial belt. This is also tilted by some angle with the equatorial belt, last four also. Okay, means this is the northern hemisphere, this is the southern hemisphere. At the same time, we can see that equatorial zone is relatively reddish in color, and compared to that, it is the mid latitude is having whitish in color, and polar regions are having again reddish in color. Relatively, it is a lesser one. Which one is gives you more energy? How the dynamics is happening. Here you can see the fantastic textures they can call. This is nothing but the dynamics which is happening on the Jupiter because of the absorption of the solar radiation and the exchange of the energy among the molecules, and also it takes the matter from one point of the not the globe like an Earth. You can also call it as a globe of a Jupiter. Okay, globe of Jupiter from one region to the another region. Maybe the possibility for the migration of the dense atmosphere and the molecules belongs to the Jupiter to move from the equatorial zone to the polar zone, and maybe from polar zone to the equatorial zone as a mixture what we are expecting on the Earth. At the same time, you can also having an easterly and westerly movement of the wind, or maybe movement of the mass. Okay, movement of the mass actually. Okay, that we can think it out. We'll see that what best we can do it. Next, today just I will show you the different pictures in the sense, okay, different representations they can say that. We'll see that. Dots or stars they can come in the background, and there are no orbits there is no circular or elliptical orbits of that kind. They preferably move in that orbit actually. You imagine like only the planets, but don't go for the orbits they can call. Okay, the same thing. But here in between, what you are expecting? Okay, my God, the sun around that you are able to see some reddish color, outer layer of that one. We'll think it out. Venus, the same case. Venus, Jupiter are having more or less. Even maybe the Uranus. Uranus, you imagine actually. Here also you might have seen that actually Uranus. Okay. Thing is that here Uranus is tilted more or less. Almost ring is perpendicular to the sun, perpendicular to the equatorial belt. They can call either of the sun or maybe for the Earth actually. Here this is tilted by some angle. Okay. And this is the comet, not be Halley, whichever way the comet which is appearing. Okay, and here also one comet of that kind. And here you can see that one belt, asteroid belt. Oh, means to say that between Mars and the Jupiter, there is one belt. Means all four planets which are near to the surface, near to the sun, are well protected, and nothing will come from outer space inward crossing this asteroid belt. This asteroid belt is nothing but actual virtual belt. It is not a virtual, it is a real actually. It is a real movement of the small massive bodies like dwarf planets or asteroids. They can call asteroids only, not dwarf planets, asteroids of masses lies with about 10 kilogram to about the mass of almost small satellites like Phobos and Deimos of the Mars. About 10,000 kilometers, sorry, not 10,000 kilometers. So 10 kilometers to about of the order of 1,000 to 5,000 kilometers in dimension, encircle the entire solar system here, entire solar system. In such a way, nothing is allowed to come in. If something is coming in, should be certainly interacted with this media. Okay, means how much dense they are there. We will see that at least. Can have this. I might have shown one diagram at that time how it rotates. Another part. The first one with Mercury, there is no inclination with reference to the equator. It is exactly there. No inclination theta. Okay, no inclination actually. It is not no tilt at all. The length of the day is 58 days. Length of the day is 58 days, 15 hours. Okay, means to complete one rotation on its own axis, Mercury moves very slow, almost double to that of the Earth actually. Means if you complete one day here, a person in Mercury will cover 2 days. Sorry, what you want to say? If a person covers one day in one day here, by that time, a person in Mercury will cover only half of that. Means only daytime will happen only will be daytime, not nighttime at all. Daytime and nighttime will have an equal interval equal to that of almost 23 hours actually, 24 hours they can call. And if you go with the Venus, oh my God, for the Venus they have put this is in the reverse order. In the sense, it is completely uplifted. Northern hemisphere is down, southern hemisphere is in top. Even though it is moving from west to east, the rotation is known as the retarded rotation. Means west to east, it appears to be moving from the east to the west. The inclination is 180 degree, almost 180 means 177 degree they have put 177 to 178 degree of that kind actually. So much of an inclination. Northern hemisphere is down, southern hemisphere is up, uplifted they can call. Earth is tilted by 23.5 degree, where the length of the length is almost about one day, 23 hours, 26 minutes or 24 hours. But the length of the day on Venus is 243 days. Length, it is moving very, very slow. This is 58 days. This is moving very, very slow, 243 days, 10 times than this value. By the time it completes one rotation on Earth, it will not complete. Or by the time it completes one rotation on Venus, Earth will have the 10 revolutions. Means now think of the year. Year is different. It is not the multiplication factor. How long it will take to complete one revolution around the sun. Then go for the Mars. It is also tilted by 25 degree. Roughly the tilt is same between the two. And it takes about 1 day, 36 minutes. Instead of 23 hours, 24 hours, 36 minutes. Slightly about some 40 minutes more compared to that of the Earth to complete 1 day around its own axis. For a day, it is 40 minutes. For 1 year, 40 into 365 you take, how long it will take? Then you come for the Jupiter. Jupiter is also same case, but it is also not tilted. Tilted is a small, very about 3 degree. And the length of the day is about 9 hours, 55 minutes. And for Saturn, oh my God, it is making so fast. Even though tilt is similar to that of 26 degree, it is tilting almost 10 hours, 40 minutes with reference to the Earth time they can call. Okay, length of the whatever the length you are expecting, the same thing. In fact, the timer is not measured only on Earth. This is the time taken for the transition of an cesium element to jump from higher orbit to the lower orbit, how long it will take. Then how much the time taken by so many milliseconds or microseconds they can call, how much the time taken by any of the planet to revolve on its own axis or to make the revolution around the sun, one can able to estimate. Time is constant, time is universal actually. It should not depend on Earth or maybe on Moon or Venus or maybe Jupiter, Neptune or maybe any of the satellites or any of the planets or any of the terrestrial system of that kind actually. Okay, here this is the same thing. Means that is the length or duration is same. Like 1 hour price of the 60 minutes and 1 minute is about 60 seconds and one day is about need not be 24 hours. 1 day is need not be 24 hours. This is the Earth day. This is the Moon day. Sorry, Venus day. This is the day for this is for the day for the Mercury and the days you can expect. But whatever the hours they have shown to complete 1 day is with reference to the duration taken by the Earth. That you have to be strong. Okay, 17 hours. Either on Earth, 17 hours on Uranus is same. Okay, but in 17 hours, Uranus will complete one rotation. Earth is relatively slower compared to that of the Uranus. Even to the Neptune, even to the Saturn, even to the Jupiter. All planets, Jovian planets will call. From Jupiter and onwards, we'll call them as the Jovian planets. Their length of the day will be smaller compared to a smaller duration, or they will complete at faster, moving at faster actually. To complete 1 day compared to that of these things actually, all of them are taking quite high actually. As you are moving inward, Venus is 10 times more than that of that. Okay, but if you come for the Neptune is also about 28 degree. This is 26 degree, 23 degree, 25 degree, almost same, and no tilt. And 180 degree, this is almost out of phase, no tilt at all. Okay, and this Uranus is considered. It is tilted by 8 degrees, almost perpendicular to the equator. Okay, perpendicular to the equator. This is the equatorial line. That is why you can't expect it. Which is on top actually? Any answer? Which is on top? Here, north is down for Venus, south is on top. For Earth, north is up, south is down. For all other, north is up, south is up. Upper hemisphere is north, lower hemisphere is south. For Uranus, Venus, actually it is about 180 degree. North is down, south is up. For Uranus, you tell which is on up.
West.
East or west?
Two things are coming. Now you tell me exactly. It is taking, you think of the rotation also. It is going and coming back. This is the north. No, from here it has to come here. This is the either east or west. Fine, actually, east or west we can find. 90 degree has from the north. 90 degree will come towards east or maybe west. Now, whether you got it or not. If you are facing north, if you move your right hand, assume that put your hand directly facing your head. Okay, take your hand right. You will be towards east. Or if you're facing towards east, north should be your left side. Okay. Or if you're facing north, right side should be your east. If it is north, which is the right side for you?
East.
It must be east. It must be east. Okay. It must be east. And then you can come for the south, then west, then north. That is why news. You are able to see the news. You are able to hear the news. What is the meaning of the news? Meaning of the news is that north, east, west, south. Sorry, north, east, then south, then west. Okay, north, east, west, south. Together information what we are getting from all the directions is known as the news, what they call actually. Okay, this is how it has to go. Based on this, my God, the space encyclopedia they can call. The solar system and its dwarf planets, how they should be there. It is there. You can't expect it. Wherever dots which are blinking is stars, which they doesn't blink is known as the white dwarfs, dwarf planets. Okay. Need not be. This is also schematic representation. Right side, you can see that. In one of the classes, somebody has asked Suma or who has asked on that time? Can somebody will come and collide with us? Suma or maybe Vijay Lakshmi, I feel that. Okay, forget it. Okay, this assume that here something is coming and hitting immediately. As something comes and hits, a portion of this I am saying there, okay, will go out, see the bottom and see the top also. Okay, in any direction, of course, depending on the kinematics, how it has to happen actually. Depending on the kinematics, how it has to happen. Because of this collision, what happens? It becomes as a debris. This heavier mass may act like a planet later, or this becomes an asteroid, or maybe a thing of that kind. These small pieces will go off. Here also small pieces which are going off may act like an asteroids later. Maybe this small piece should, all these pieces should have the property of this heavenly body. Either from the left, what you are seeing towards you, or maybe from the rear end, what you are getting actually. Either the pieces of this one or maybe this, we don't know, or maybe the combined effect of those two also. It will also collapse, that will also collapse, which is moving, we don't know. But both these portions, small pieces should be the outcome of, should be the broken pieces of these two heavenly bodies or celestial bodies. Okay, being this, with a comparison, Sun at one of the focus, and all planets are encircling. The first one with Mercury, my God, they have put the diameter about 0.4 angstrom as the diameter. Okay, this is about 0.7 astronomical unit as the diameter. You can say that you can take some spatula and hold it. Okay, you can hold it with 0.4 AU astronomical unit actually. Okay, and this is about 0.7. 1 AU is equal to the diameter of distance of separation from the Earth and the Sun actually. This is about 150 million kilometer. 150 million kilometer is as that of this value, and Moon somewhere here. Then this is another one. Asteroid belt you will get somewhere here at the fourth one. Okay. Then after that are Jupiter about 5.2 astronomical unit. Wood clouds, some of the wood clouds will come here actually here. Okay, this is the wood cloud, portion of that wood cloud. This is the Saturn, the enlarged image. This is also an enlarged image actually. Okay. Then maybe the Neptune, maybe Pluto of that kind. This is another image. I'll stop here. Then we can think it off how best we can do it actually. As far the case is considered particularly, I have to go ahead with the rest of the part. Stop sharing. Sharing here. I will show you what is a new share. Uh, can you able to see the screen?
Yes, sir.
Okay, okay. You can also watch. There is no doubt. Solarsystem.nasa.gov.in actually here at free time. See that I'm increasing. Today is the June 9th, 2021. What is the local time? 3 o'clock, 53 minutes, 17 seconds. Where I am sitting. What is the time in your location? Suma. Suma has left.
3:53.
All of them are having the same thing. All of them are having the same timings actually. Let it be the solar system, how it revolves. Okay, because time will not change from person to person throughout the India. We can have same timings because that is known as the Indian Standard Time, refers to the Allahabad latitude. Latitude. Here, what I want to say is that actually see the position of the different stars. Tomorrow is the eclipse. What you are expecting? Okay, Sun is here, Mercury is here, Mars is here. Okay, here in the sense in the system you can able to see, or I will change this, let it be. Okay, this you can change the phase. Where is the Earth? Earth is here. Earth is here. Okay, they are coming. This is the right time. This is they are like this. There is no problem. This is the epoxy site they can call. Sorry. This is Parker Solar Probe is moving somewhere at this point. My God, I have to bring it down. It's not taking. Okay. We are about 200 plus moons, about more than 1 lakh asteroids. Okay. My intention is that to show you the conjunction between the eclipse. This is the Earth. Okay. Here, assume that can you see that Earth and Sun is there? Always will be there linearity between the Earth and Sun. If you expect the moon, how it has to happen? How it has to happen? Somehow I missed. Okay. Otherwise, you will do one thing. Time and date solar eclipse you can go. This is the 10th June, tomorrow. Just see here. Moon is coming and trying to obstruct. Altitude is about 22 degree, 22 degree, 20 degree. Direction is about it. My God, this is known as the what you can call ring of fire. Ring actually, not ring of fire. Ring of fire also. Full eclipse. At what time? Just think. Date and time, whether it is visible or not, also you can see that, not an issue. But Earth, Moon, and Sun, they are at perfect distance. Earth, Moon, and Sun, they are at perfect size. Earth, Moon, and Sun, they are at perfect inclination. Earth, Moon, and Sun, they are exactly this spherical. If not, you can't expect this type of an eclipse. The distance 108 they can call. The ratio of size of the Sun to the size of the Earth, if you take 108. Ratio of size of the Earth to the Moon, if you take 108. Size of the Sun to the size of the Earth, 108. Size of the Earth to the Moon, you can take 108. Distance of Sun to the Earth, you can take 108 times that of the distance of separation between the Earth and Moon. Or if this 108 what you are getting, this number exactly fits. Right now, hold your hand, put your finger, tip finger ahead of you. Tip finger ahead of you. If not, I will also show this. Just I will keep one thing. How can I come to you? Let it be camera. Let it be on. Can you see me right now? If you put your finger, okay, then bring near to one of your eye. Even a small finger can close your eyesight to a great extent across the world in that angle. Otherwise, means the size has to match in such a way. See, making full circle. My God, close. It will continue. If you continue the same case where it is appearing the path of this one, it has to go with Anelama. This is the path. Search your location, for example, Bangalore. Are you able to get it or not? Not visible in this location. Okay, because it is partial. See the diagram here. Instead of this. This is the location. This is the location of what we can call as the sun, which is creating an eclipse part of it. Okay, just go through it. Right now, almost we are about 4 o'clock. I'm having one more commitment. You can see that. And if not, here, what I want to say, they will also give 3D path of the cloud. Yeah, see that. This is, you can rotate it like that. This is the penumbra, where is the darkest one is there. This is the lighter part. This is the lighter part of that kind. Being like this, where to get actually here. Yeah. India is somewhere here. This part of the globe will get the eclipse. Means moon will moon has to obstruct for the shadow. Moon will come in between the earth and the sun actually, where it creates the shadow of that kind. This shadow may not influence to a great extent. Whether we are really getting influenced, yes, we are really getting influenced by the shadow, not by the rest of the path. Earth is here, sorry, not Earth. India is somewhere here actually. Only mid latitude and polar region gets encircled. This is the one. One more thing, live stream you can go, you can witness. It starts at about 11:32 IST and ends by 17:32. Because almost 5 o'clock, 3 to 4 o'clock we'll be somewhere here. We'll discuss more. Can I request all of you to prepare and tell about something which is special about the eclipse? Need not be solar eclipse only. Need not be particular eclipse. Need not be particularly tomorrow eclipse. All eclipses are of the same kind. Just prepare it, maybe orally. Need not be with slide and other part. We will discuss and we'll have the interactions to a great extent. Thank you, one and all. I will close sharing right now. Stop sharing. Then, if there are queries, I am very happy to address. If not, we'll move on to next class. If
Sir?
anyone, your suggestion. Yeah.
ಸರ್ ಅವಾಗ್ಲೇ ಹೇಳಿದ್ರಿ ಊಟ್ ಕ್ಲೌಡ್ ಅಂತ ಸರ್ ಹಂಗಂದ್ರೇನು ಸರ್?
Oort cloud means they have given the name for all asteroids like Kuiper belts. Oort cloud is a kind of a cloud which encircles entire solar system at a distance of about 1 lakh astronomical unit. Kuiper belt, you told no, I told no, it's Kuiper belt, like Kuiper belt, like asteroid belt, and another belt is the Oort cloud they can call. That cloud moves, encircles entire solar system at a distance of about 1 lakh astronomical unit from the earth, or maybe from the sun. Astronomical, more or less same thing, more or less.
So what is the difference between the Oort cloud and normal cloud?
No, clouds are nothing but the floating objects. Oort clouds are the debris or maybe the meteoritic dust or some kind of a particles which are suspended in the space, not in the air.
Okay, sir. Thank you.
Which are suspended in the space. Okay, about eclipse you prepare. Those who are here, Shalini, Aish, Arpita, Naresh Babu, Vijayalakshmi, Suma, and you also tell about to inform to others, particularly Vahidaban. Thank you. Shall I end the class?
Okay.